Welcome dear children, myself is Sunil, your physics teacher. Good morning to one and all. How are you students? Fine? I hope you all are fine. You are enjoying holidays, okay? So, we have already started our second chapter, that is motion, okay? And today from this chapter, we are going to start one more important topic, that is circular motion. Okay students, all of you please take out your book and ready to watch this session carefully. Okay students, you can see here in the diagram a boy is doing one activity. Have you done this activity any time in your life? Did you play like this? Okay, you see the movement of ball here, you see movement of the ball in a circle. The ball is moving in a circle. Okay. Okay students, so here in this type of motion we are going to discuss today, that is circular motion. Yesterday we have discussed rotatory motion, okay, and what is the difference between rotatory motion and circular motion? We are going to discuss today. The motion of a body along a circular path is called circular motion. The motion of a body along a circular path is called circular motion. Okay students, circular motion is a special type of curvilinear motion in which the distance of a moving object from one place to another. But its center does not change. The body is moving from one place to another. Here you can see the first diagram. The body is moving from one place to another. It is rotating. It is moving in a circular way, but the center, you see, it is not changing. It is a fixed point. It is fixed. Okay, fix it. For example, in figure 2.6, a girl is whirling a stone tied at the end of a string in a circular path. The other examples of a circular motion are the motion of a car around a circular path. Clear? The motion of a car around a circular path, the motion of hands of a clock, and the motion of a satellite around the earth. You can see motion of a hands of a clock. The center is fixed. Clear? The motion of satellites around the earth. Here also same concept. These are all examples of a circular motion. In rotatory motion, the axis of rotation passes from a point in the body itself, whereas in circular motion, the axis of revolution passes through a point outside the body. Thus, the motion of a satellite around the earth is a circular motion, whereas the motion of earth around its motion is on a particular axis, that is called rotational motion. In a circular motion, the distance of a point of the body from a fixed point always remains the same, whereas it is not same in curvilinear motion. The hour hand of a clock takes 12 hours to complete a circular motion around the clock, while the minute hand takes 60 minutes to complete a circular motion around the clock. If you consider the hour hand, the hour needle of a clock takes 12 hours to complete a circular motion. And the minute hand, if you observe the minute hand, it will take 60 minutes to complete a circular motion around the clock. The circular motion is thus periodic and repetitive. So we can say that the circular motion is periodic and repetitive motion. Okay. Now we are going to discuss about another type of motion, that is oscillatory motion. Oscillatory motion. The to and fro motion of a body from its rest position or mean position. Rest position can be say that mean position. The to and fro motion of a body from its rest position is called the oscillatory motion. For example, the motion of the pendulum of a wall clock and the motion of a swing represent oscillatory motion. In this, the bob of a pendulum from its rest position O moves to one side A, comes back to the rest position O, then moves to the other side B, and then again comes back to the rest position O. This process is continuously repeated, starting from one point and going back to next extreme position, then coming back and going to the same position from where it is started. It is called to and fro motion. The motion of a pendulum, the to and fro motion. This process is continuously repeated. Since the oscillatory motion is repetitive at a regular interval of time, it is also considered as periodic motion. It is also considered as periodic motion because it is repeating at a regular interval of time. Okay students, here you can see clear both situation. First one, the motion of a pendulum of a clock. You see, from A it starts and reaching to O, then finally it reaches to B. Then from B it starts to go back or comes back to the original position A. So it is an oscillatory motion. Another one example, motion of a swing. Maybe you have played this one, okay? You like this game now? Okay. This game, this motion of a swing is a good example of oscillatory motion. It is an oscillatory motion. Now we are going to discuss about vibratory motion. It is also an oscillatory motion with the difference that in vibratory motion. What is the difference? A part of the body always remains fixed. One part of the body that will be always fixed. That is the difference between vibratory and oscillatory motion. One end will be fixed, other end will be in a to and fro motion. The rest part moves to and fro about its mean position. Keep a scale on the table and one side you fix with your hand and move it. Clear? What will happen? And just to move it. Stretch downside and leave it. What will happen? The scale will start to vibrate. Clear? During the vibratory motion, the shape and size of the body changes. Shape and size of the body changes. Some examples we can discuss here. In figure 2.9, clear? Maybe you have done this activity by the rubber band. Stretch in your mouth and do it like this. What will happen to it? The rubber band starts to stretch. Okay students, the rubber band starts to vibrate. Sorry, the rubber band starts to vibrate. Here is same activity. Clear? A wire is stretched between two fixed rods A and B. A wire is fixed in A and B on the table. As the wire is plucked, we are going to plug the wire. We are going to plug the wire. what will happen? It starts to vibrate, okay, starts to vibrate, okay. As the wire is plucked and released from the middle, it starts moving to and fro. So it's a type of vibratory motion. Now next one, our vocal cord vibrates. Just to touch your vocal cord by saying something. You can feel the vibration of the vocal cords. So our vocal cords vibrate to produce sound when we speak or sing. You sing a song or say something, okay? You can feel the vibration of the vocal cords. The vibration of the membrane of a tabla. Do you know how to play tabla? Okay? Okay, just do it. You can feel the vibration on the membrane. Just do it simply, okay? Simply you do it. If you don't know also, just simply you do it. You can feel the vibration of the membrane. The vibration of a membrane of a tabla when played is a common example of vibratory motion. Most of the musical instruments like guitar, violin, sitar, etc. have strings attached to them so as to execute vibratory motion when they are played. Most of the musical instruments based on the vibratory motion. Okay. Vibratory motion can be demonstrated by the following activity. Now we are going to do one activity, okay? I have already explained to you this activity, okay? To demonstrate vibratory motion, take a metallic strip or metallic scale, okay, steel scale, okay students, steel scale, you don't forget it, the steel scale nowadays, okay. Okay, take one steel scale or metallic strip, fix its one and OH on the table, clear, on the table as shown in figure. Thus OA is the rest position of the strip, OA is the rest position of the strip here, OA, the rest position. And what we are going to do in this activity, now lower the end A of the strip slightly and then release. Just lower the metallic strip down, clear, stretch the metallic strip down and just release it. What will happen? It will start to vibrate, it will start to vibrate. The strip will start vibrating from A to B and B to C and then C to A and so on. It starts to vibrate. It is a good example of vibratory motion. Okay students, now we are going to discuss about periodic motion. What is the definition of periodic motion? What do you mean periodic motion? A motion which gets repeated after a regular interval of time is called a periodic motion. A motion which gets repeated after a regular interval of time is called a periodic motion. Examples. We know that Earth completes one revolution about the Sun in 365 whole 1/4 days. To complete one revolution around the Sun, Earth takes these much days. And this motion is repeated after every 365 whole 1/4 days. So we can say that this is a good example of periodic motion, because the revolution gets repeated at a fixed interval of time. Second example is the moon revolves around the earth. The moon revolves around the earth and completes one revolution in 27.3 days. It takes 27.3 days and then repeat this motion. The moon revolves around the earth and it takes 27.3 days to complete one revolution. And then it repeats this motion. So this is also a good example of a periodic motion. And also a normal person's heartbeats, you know, just to take the pulse, its time interval is 0.8 seconds. It repeats in between 0.8 seconds. The heartbeats. So it is also a good example of a periodic motion. Now another one familiar example is the pendulum of an old clock. That movement will repeats after every 2 seconds. So it is also a good example of periodic motion. The other examples of periodic motion are the motion of a needle of a sewing machine, and the movement of membrane of a tabla when played. The movement of membrane of a tabla when played are all examples of periodic motion. Okay students, now we are going to discuss about another type of motion, that is non-periodic motion. Periodic motion, we know that a motion which gets repeated after regular interval of time. But what about non-periodic motion? The motion which does not repeat itself after a regular interval of time. Periodic motion, it gets repeated after a regular interval of time. Same time, what is non-periodic motion? In this type of motion, the body does not move at the particular interval of time. There is no particular interval of time to move it. Example, a footballer running on a field, whether he is having any time to catch the ball, to kick the ball and all. No, there is no particular time. When he gets the ball, he will kick and he will run here and there. Okay. So it is a non-periodic motion. Another one, application of brakes in a moving vehicle. Application of brake. Maybe you are riding the bicycle, okay? When whether there is any particular time to take the brake, to get the brake, to apply the brake? No, there is no particular time. So it is also a good example of non-periodic motion. And also a ball rolling down the ground gradually slows down. Once you are kicking the ball, what will happen? First it will move in a speed. Clear? And later it slows down and finally it will stop. Whether there is any particular time to stop? No. So it is a non-periodic motion. And the motion of tides in the sea, whether there is any particular time? No. So these are all examples of non-periodic motion. Now there is our fascinating fact. Do you know? We have already discussed that in chemistry, states of matter. In case of liquids and gases, the particles are arranged very loosely. So the particles in a liquids and gas, that will move in a zigzag motion. So this is also a good example of non-periodic motion. Clear? Zigzag motion. Now we are going to discuss about the mixed motion. This point we will discuss in tomorrow's class. Till then, goodbye and have a nice day.